Afternoon. So I'll be running through Pei Chun Public School Primary 6 Term 1 weighted assessment. This paper was actually a 2024 paper. So there's a total of 16 MCQ questions in this paper. So without further ado, let's start from question 1. So question 1 is really about digestion. So you have a human digestion systems over here. And it shows you different letters that represent the different organs in the human digestive system. So A will be your mouth, okay, B will be your gullet, C will be your stomach, okay, D will be your small intestine, okay, and E will be largely your, which is pointed to this part, is your large intestine. Okay, so from here, which of the following correctly describe the functions of A to E? Organ that produce digestive juice. Any organ that carry out digestion will produce digestive juice. So these are the three organs that will do digestion: mouth, stomach, small intestine. So A, C, D. So definitely these two is correct. The rest is wrong. So you are dealing with 3 and 4. Organ that involve absorptions of food. Okay, so notice absorption of food, not water. Okay, this one must be done in the small intestine. So answer is number 3. Okay, moving on to this part. The diagram shows the different paths taken by food and water in a plant. A, B, C, D represent different parts of the plant. So you have a bow arrow and a dotted arrow, which represent food and water. What do A, B, C, D represent? So to really deal with this question, right, you have to look at where the arrow start from. Let's say for food, right? The arrow, all of them, they come from here. They come from this point. So you straight away, you probably know that A is a place that produces food. So it must be leaf. It is the site where it carry out photosynthesis. Okay. Likewise, you do this for water. See where all the dotted line reach. Okay, it start from here. Okay, this one also start from here. You backtrace the arrow. So this is the place where the water starts from. Okay, so this one will be your roots. Okay, so C is your roots, A is your leaf. So you just work it out accordingly. Leaf, roots. So straight away you probably know that number 1 is your answer. Okay, but you want to further confirm, right? For B, right, this part is your stem. Okay, this part is the part where it connects between the leaf and the roots itself. So the food that is being produced in A, right, will transfer to the stems and followed by to the roots itself, and then both the food and water will end up in D. Okay, for this part. Okay, so D is usually your flower or your fruits. Okay, where it does not produce food and water, you have to take in from somewhere. In this case, it takes in from your stem itself. Okay, the table shows the type of gas in the air that are taken in and out by human. Okay, so these are the 4 gases that you probably need to know: nitrogen, oxygen, carbon dioxide, and water vapor. And these are actual data that has been given to you. So based on this information which is in the table, which one of them is incorrect? So which of the statement is actually wrong? Okay, water is lost through breathing. This is correct because when you taken in is 1, you given out it's actually more. Okay, so the data or actually the evidence over here supports this statement. So this is correct statement. Okay, all the oxygen that enters lung goes into the blood. So trying to say that all the oxygen that has been taken in will be absorbed into bloodstream. So if this is true, then the air given out will be at 0%. So you take a look at this. It is not true. Okay, taken in is 21, given out it's 16. So it suggests that only 5% enter the bloodstream. Okay, and only 5% enter the bloodstream. So this is actually the wrong statement. Okay, and at least 4 types of gases enter the respiratory system. Yes, okay, these are the 4 types. Okay, carbon dioxide is produced by the body and is released in the air. This is correct because if you take a look at the carbon dioxide, which is this part, 1% become 4%. So your body suggests to you it produce at least 3%. Okay, and this is produced during respiration process. Okay, when your body is producing energy. So number 2 is the correct answer. This is actually one of the misconceptions that students commonly have. Okay, students often assume that all the inhaled oxygen is being absorbed in the bloodstream. This is wrong, huh? So because sometimes usually when we are studying this topic, we will take the function of the respiratory system as take in oxygen, give out carbon dioxide. This is correct, but not all the oxygen is taken in. Some of this is being released through exhalation. So this is something that you probably need to take note. Okay, so we take in oxygen, that's true, but not all of the oxygen has been absorbed into the bloodstream. Okay, moving on to question number 4. So 4 students make the following statement about function of stomata. Stomata is actually the tiny opening found on the leaf. Okay, usually they are found on the leaf, and they are responsible for gaseous exchange with the surrounding. So exchange of gases happen all the time. This is correct. Okay, no matter during daytime or nighttime, the plants will carry out gaseous exchange. And this gaseous exchange is really for 2 processes: photosynthesis plus respiration. Respiration happens all the time. Photosynthesis happens when there is light. So Eric is correct. So water vapor is released to the surrounding. This is correct, true. Okay? When the stomata is open up, water vapor will be released into the surrounding. This is wrong. Okay, water vapor is absorbed from the surrounding. No, water vapor will not be absorbed from the surrounding through the stomata. The plants take in water through the roots by absorption. So this is a wrong statement. Okay, we are just cross. So actually from here, anything with red, right, is straight away wrong. So your answer only left with 1 and 2. And if you know that Eric and Faith is correct, right, then your answer naturally will be number 2. Okay? So let's take a look at the last statement. Hannah said that exchanges of gases only happen during photosynthesis. Wrong. Okay, also happen during respiration. Okay, the plants also respire, it also need gases. It will also exchange gases, and this will happen all the time. Okay, so the main idea is that during the day, right, the stomata will be open wider so that it can take in more gas to allow photosynthesis to happen at higher rate. So, but during the night, the stomata is slightly closed. Okay, this is to still allow gases exchange, but just for that respiration process only. During the day, there will be photosynthesis and respiration, but photosynthesis usually happen at a higher rate as compared to your respiration. So over here, this is a misconception. The stomata do not absorb water vapor. Okay, for this part. Okay, let's move on to question number 5. Okay, the diagram shows how blood flows in a certain part of the body after a few hours after meal. Okay, a few hours after the meal compared to the blood in Y, the blood in X. So the focus is this. This is the focus. Okay, not Y. So we take a look. Okay, the lungs flow into the heart. So this one should be the rich in oxygen. Okay, this is also rich in oxygen, but less rich. Okay, after the blood passes through the body, which is labeled as small intestine over here, this part will be poor in oxygen. Okay, so over here, if we compare X and Y, right, X will have less oxygen because it's poor. Okay, so naturally, you know, this one is correct, this one is correct, 3 and 4 is wrong. So now we are determining whether it has more or less digested food. So now you have to recall the function. Function of small intestine, okay, is to absorb digested food into bloodstream. Okay, so based on this, right, then the blood that is coming out, from small intestine will have more digested food. Okay, so the blood that's entering the small intestine will have less. So this one should be number 2. This one is really linked to your small intestine. So this is the answer here will be number 2. Okay, moving on to question number 6. Ahmad placed 3 solid blocks X, Y, and Z into a beaker of water. His observation is shown below. Make 2 statements. A, X, and Z are the same material. Okay, take a look. X and Z are the same material. Okay, so he's suggesting this is because, right, X and Z sing. Okay, so they must be the same material. Okay, is it true? Or can you even conclude this? The answer is no. Okay, because I'll give you an example. This could be metal. This could be ceramic. Both sing, but they are not different. They are different material. So you cannot conclude this material. The idea is that there's actually many items that sings in this world. So you cannot say any item that sings, they are the same material. Okay, this is a wrong conclusion. Let's take a look at B. Okay, Y and Z are different material. So you take a look. Y and Z, yes, one float, one sing. Float, sing. Because of the property of the material, they are very different. So they must be made of different material. This is something that we can conclude. So we can conclude only B. Okay, number 2. So this will be part of the explanation. So I'll just pause here for a while. X and Z is the same material, but while both of them can sing, it doesn't mean that X and Z, they are made of same material. There are many materials in this world that still can sing. And so that's why we cannot conclude this statement, or this statement is actually a false statement, because there is a way to argue it around. Okay, next up for B, Y and Z, different material, one float, one sing, so they must be made of different material because they have different property. Okay, so B can be concluded. So question number 7 is really a question on photosynthesis. Okay, and there are a few factors that will affect the rate of photosynthesis. One of them being light, the amount of carbon dioxide. So this factor will be temperature as well. Okay. So concluded an experiment in dark room using a setup below. She measured the amount of gas collected in the measuring cylinder after some time. So you take a look at this setup. Okay, you have a lamp. This is your light source. So the light will hit the water plant. The water plant will photosynthesize, and some gas will be collected. This gas that will be collected will be, we will normally assume them to be your oxygen, because we will take it that it is a photosynthesis process. Okay, so there's tracing paper that allowed some light to pass through. This is trying to suggest to you that this material, it is translucent, and it will block some light, allowing less light to pass through. So can they repeat the experiment by increasing M? Okay, keeping all the rest of the variable constant. Her result is shown below. The amount of gas collected and versus M, right, is plotted in this graph. And first thing first, you notice that the bar is getting lower and lower. Okay, so it's trying to tell you one thing. It's a decreasing relationship. That means if you add more M, the oxygen gas collected is going to decrease. So it suggests to you what? Rate of photosynthesis decrease. So you got to look at the factor that causes the overall rate of photosynthesis to decrease in the listed variable given. So number of water plant. So if you add more water plant, right, there will be more gas being produced. Okay, more gas being produced. Because more water plant, more higher rate of photosynthesis, more gas is being produced. So this is wrong. Okay, this does not, why this is wrong, does not match the graph. Does not match the graph. Okay? This statement just does not match. We must find a decreasing relationship. So if you add the number of tracing paper in front, right? Yes, because if you add more tracing paper, more light block. More light block, less light reaches the plant. ROP, which is rate of photosynthesis, decreases, less gas. Okay, so this is correct. Distance of the water plant from the lamp. So you have to read this very carefully. He's trying to say that the distance of the water plant from lamp increases. So now the lamp, okay, this is the lamp, right? And this is the plant. Okay, so he's trying to say that the lamp increases in distance. Okay, so if you increase the distance as compared to just now, there will be less light reaches the plant because the light source is further away. So same thing, ROP decreases, less gas. Correct. So B and C fit into this scenario. B and C fit into this scenario. Okay, so for D, right? No. Okay, D is no go. Okay. Okay, why D is wrong? Because if you increase more carbon dioxide in the water, there will be more carbon dioxide available for the plant to take up. So having more carbon dioxide for the plants to take up, ROP, which is rate of photosynthesis, increases, more gas. More gas being produced. So this also does not fit into the graph. Same like this reason over here. So only B and C fit into the graph. Then the only option with B and C will be number 3. So number 3 is the correct answer. Okay. Okay. Move on to question number 8. Okay. Question number 8. You have to look at both diagrams at the same time. So he lowered a U-shaped magnet into a tray of iron pins, which is a magnetic material. I'll just put MM in short, that can be attracted by magnet, as shown in diagram 1. Diagram 2 show the bottom view of the magnet. So if this is lowered, then it will attract some iron pin, right? So then they ask you which one shows the most light, which of the following most likely shows the number of iron pin attracted to the magnet at position K, L, and M. So you have to analyze K and M. They are at the poles. Poles strongest. So it should have the most number of iron pin attracted. As compared to L, right? This is the middle. Okay, middle. So it should be the weakest. So if it's the weakest, it should have the least number attracted. K and M should have equal number and higher than L. Okay, so this is the conclusion. So we take a look. Number 1, not possible because they are all the same. And number 2, K and M, they are lower, while L is higher, also not possible. So you take a look at number 3. Okay, basically it's the reverse of number 2. Okay, K and M is of a higher value, they are the same, and L is lower. So this one is the correct option. Number 3 is the correct answer. Number 4 is wrong because it's trying to suggest that M is actually the weakest part of the magnet. So this is also wrong. So number 3 is the answer. Okay, for question number 9, in the setup below, the bar magnet is repelled. Okay, this is a repulsion. Okay, repulsion that we're looking over here, repelled by the electromagnet. The distance D between the two magnets is measured when the circuit is closed. So when the circuit is closed, this bar will become magnetized, so it will become electromagnet and repel iron bar. Because why they repel? Because over here the light poles are facing each other, causing repulsion. Okay, repulsion. So let's take a look. Which of the following shows how D and the strength of electromagnet changes when one battery is being used? So 3 battery become 1 battery. So when 3 battery become 1 battery, right, the strength of the electromagnet would decrease. This one will decrease. So we look for the decreased one first. Wrong, this one correct. So we only left with number 2 and number 3 to choose from them. Okay, so between these two, right, if you think about it, okay, there's a spring over here and there's a bar magnet, okay, and there's an electromagnet. We just zoom into this part first. Okay, analyze this part. Okay, this part will be much easier. Okay, if you have 3 battery, stronger electromagnet, okay, stronger electromagnet, okay, so the repulsion will be stronger, right? So D will be larger because the repulsion is stronger. So now if we were to do a reverse thinking, so if one battery, so it will be a weaker electromagnet, so the repulsion will be weaker and D will be closer together. So we are trying to suggest that D actually decreases. Okay, if you think from this train of thought. So then therefore number 3 would be the correct answer in this case. Okay, so that will be the answer for question 9. So now we move on to question number 10. Okay, identical batteries and bulb were used to set up 4 circuits as shown below. So we have 4 circuits. So which of the following arrange the bulb in increasing brightness? Increasing means from small the number to big number. So it's from dimmer to brighter. So which one will be the dimmer one? So you take a look. Actually, if you want to look at it, right, all of them has same number of battery. So the units or the amount of electricity flowing through the circuit, right, should be the same, but they are not the same for each part because they are arranged very differently. So this is one way that you can do it very mathematically. So let's zoom in as one. So if you take a look at where the part P is, electricity will flow through this way. Electricity flow through this way. Okay, over here. Okay, so each one battery is 2 units, and 2 batteries will be total will be 4 units of power. So the electricity flowing through is also 4 units. 4 units in total, but it's being shared with 2 light bulbs. So P will be number 2. Okay, 2 units of brightness. 2 units of brightness. Okay, 2 units of brightness. Okay, let me rewrite this. 2 units of okay, now we move on to Q. So same thing, electricity flow through Q this way in this manner. So it is still same 4 units. Okay, but this thing divided by 3. So each light bulb will have total power will be 4 divided by the number of bulbs will be 3. So here will be each bulb will shine with 4/3 units of brightness. And you move on to R. There's a way I'm doing this method mathematically. So same thing. So you have 4 units of power divided by 4 bulbs. 4 divided by 4 is 1 unit. So this will shine with 1 unit of brightness. So from here, right, you most likely know that which one is the dimmest. Okay, R is the dimmest, followed by Q. Okay, and followed by P. Then last one is actually S. Okay, why is this S? Electricity flow through this way through S. So the amount of electricity flow from this blue color path is 4 units, and there's only one bulb in this pathway. So 4 divided by 1 is still give you 4 units of power. So if I were to rearrange this mathematically, using this method, so the dimmest and the brightest. Okay, so first will be R which is 1, then followed by Q, which is 4/3, because 4/3 is larger than 1. Then we have P, which is 2. Then last one, which is S, which is 4. So from the smaller number to the largest number in this manner. So this is one way that you can do it very mathematically. Okay? Assume each battery to be 2 units of power, then trace out the electricity flow and look at how many bulbs is sharing through that electricity flow over here. Okay? Then you take the total power from that battery, you divide it by the number of bulbs. And then you will get the brightness of each unit. Brightness of each bulb. So in this way, then you take a look. R, Q, P, S. So number 3 will be the correct answer in this case. So moving on to the next question. Okay, next question. But B1, B2, B3 and switch 1, S1, S2, S3, they are connected in a circuit as shown. All bulbs and battery are connected properly. So you take a look at this circuit diagram. And there we have a battery in the middle, and it seems like we have 2 circuits. Okay, one is going this way, the other one is going through this way. Okay, so we have 2 paths. Okay, so let's take a look at the blue color one. Blue color, which switch are involved? S1 and S2. There's 2 switches involved, and the bulb that is involved is B1. So for the red color path, okay, red color path, S2 and S3 are involved, as well as B2 and B3. So these are the ways that electricity can flow through. That means, right, if I want B1 to light up, these 2 must be closed. If I want B2 to light up, S2, S3 must be closed. Likewise for B3. So you can see the common switches between the blue color path and the red color path is this, the common switches. So S2, if it's open, no bulb will light up. No bulb will light up. So you take a look, actually from here, you can take a look. S2, open. So if you see a yes, right, straight away wrong. Because all of this should be no, right? Because S2 control all the bulbs. Okay, so you know 3 and 4 is wrong. So you only need to look at 1 and 2 and analyze them accordingly. So number 1 says that if S1 is closed, okay, and S2 is closed, S3 is open, then we will only have S1 and S2 are closed, S3 is open, right? Then we only have B1 light up. B1 light up. But you can say, look, B2 also light up. So we surely know that this is wrong. Okay, so answer must be number 2. But we have to analyze, because for 4 of them, there must be one option correct. So they say S2 and S3 are closed while S1 is open. Okay, S2, S3 are closed. Okay, while S1 is open. So they look S2 and S3 closed, then B2, B3 light up. B2, B3 light up, yes, B1 no. Okay, so answer must be 2. So this is one way that you can do it systematically through this method. Tracing the electricity flow is very important in this kind of question to be able to analyze whether the situation, or sometimes what we call the observation, right, fit into the result. Okay, this is the result, whether the bulb light or not. Okay, so this you have to basically use the evidence or the observation being provided in the table to see whether it match. Is a evidence matching, okay, with the result that is given. Okay, so let's move on to question number 12. 12 is slightly a little bit more difficult. Okay, because this question is on force. Okay, force. A mass is hung on a spring as shown in diagram 1. The mass is pulled downward as shown in diagram 2. So the difference between 1 and 2 is that both of them have mass hung on them, but 2 have this pulling force exerted on the object by the hand itself. So let's take a look at this diagram 1 very carefully. So this part, that is a gravitational force. acting on it. And the amount of gravitational force acting in both diagrams, they are actually the same. Because the mass, they are the same. So if I were to do this, right, I can actually write it in this way. But for diagram 2, right, they have a extra pulling force by the hand. Pulling force by hand. Okay, so the spring, right, in this case, it is being extended longer. So when it's extended longer, there is elastic spring force exerted by the spring on the mass. Okay, there will be elastic spring force because the spring is extended in this case. So the elastic spring force will be somewhat in this manner because it's long, it's extended longer and it will be in an upward direction. Likewise, for diagram 1, right, there will be elastic spring force because the spring is also extended. Okay, but it's extended shorter. So the amount of elastic spring force exerted by the spring onto the mass, it's slightly a little bit shorter. So you can see the length of the green arrow on both diagrams, right? They are trying to say the amount of force. Okay, the amount of elastic spring force to be exact. Okay, and the length represents the amount. Okay, the longer it is, the more elastic spring force exerted by the spring on the object. So you can see this is longer, right? So this has more elastic spring force. This has less elastic spring force. So normally in the topic of force, right, the length of the arrow represent the amount of force, and the direction of the arrow represent where is the direction exerting on the object. Okay, so in force, these two things are quite important: the amount of force and the direction. Okay, these are two things that you need to be able to pick it up at least from the diagram itself, and sometimes it can be quite hard for you to do so because you cannot see forces. You can only interpret from the diagram itself. So which of the following correctly compares the gravitational force and elastic spring force acting on a mass in diagram 1 and 2? Gravitational force, they are the same. Okay, because the mass is the same. Okay, so 1 and 2 out, so left 3 and 4. Okay, between 3 and 4, right? Okay, you see greater in diagram 1, I already say it is less elastic spring force, so the answer must be number 4. Okay, for the elastic spring force exerted by the spring on the masses is less because the spring is less extended. Okay, let's go on to question number 13. Okay, question number 13, right, is actually a PSLE question from 2021. This question is question number 23 during that year. Okay, this is actually quite a famous question. Take a look, the car is being parked on a slope. Okay, car is being parked on the slope. So Raymond and Laura open the door from a different side. Both of the door have the same mass. Same mass. Which of the following is or are correct? Okay, the force used to open the door. Okay, because over here, right, the door, right, this door, right, that is opened by Raymond, right, it is the same direction as gravitational force. Same direction. So actually, Raymond needs less force to actually open the door. Less force. Okay, but for Laura, right, this door, when she want to open, right, is against the direction of gravitational force. Okay, this represents gravitational force. Okay, let me write it down. Gravitational force. Okay, it's again. So she will need more force to be able to open that up because she's going in the direction. She's going against the direction of gravitational force. For Raymond, she's going along with the direction of gravitational force. So Raymond need less. Laura need more force, more pushing force to actually open up the door. So I would say Laura direction should be somewhere here. Can you see the length of the arrow is longer? So over here, let us analyze since we really get a main idea of what's happening in the diagram. Both Raymond and Laura can use equal. Wrong. Because I already said they have to use different amount of force to open the door because they are on a slope. Okay, so gravitational force acting, this is wrong already. So number 1, Raymond used smaller force. This is correct. Force is exerted against, not against, it's along. So this statement is wrong. Force exerted by Raymond is along with the gravitational force, or it is in the same direction with the gravitational force. That's why less force is needed by Raymond. So number 2 is wrong because of the explanation. Number 3, Laura has to use a larger force. That's correct. So number 4 is wrong, because smaller. I already see that Laura need to use larger because force is exerted against the direction of gravity. This is correct, number 3. Because if she's going against the direction of gravity, so she will need more force to be able to open the door of the same mass as compared to Raymond itself. Okay, so let's move on to question number 14. Megan conduct experiment using spring X and Y, each of length 2 cm. That means this is the original length. Okay, of the spring. She hung various load one at a time and record the extension of the spring. The result is being shown over here. So, which one of the following correctly shows the length of spring X and Y when a load of 300 was hung on both springs? So, 300. This one is actually information reading on the graph. Okay, first you have to identify that the extension is this actually record extension. That's why the line start from 0. It doesn't start from 2. Okay? If it start from 2, right, then this will be the total length of the spring. Okay, then this will be total length. Okay, so this is telling you that how much the spring extended. So after you calculate, right, you still need to add on to the original length. Okay, so take a look, 300. So if you were to draw a line up for Y, right, it means at this point. For Y, it means at this point. So then you just move it along over here. Then how to know how much the spring extended? 0, 1, 2, 3. So Y extended by 3 cm. So you still need to plus 2 cm. So the total length, okay, because they want the length of the spring, which suggests the total. The total is 5 cm. Okay, total is 5 for spring Y. Okay, then for spring X, same thing, 300. You go up all the way. Over here, it meets here. Okay, for spring X, okay, then you look, okay, it reads 6. So it tells you that extended by 6. So 6 cm plus 2 cm. So the total length is 8 cm. So based on this calculation, number 4 is correct. Number 4 is correct. Okay, some of you may have choose number 3. Okay, because you just read off the information, but you have to know that in spring, right, it can be quite tricky. Reading this part very important. Okay, this part. Okay, because it will actually determine how your answer how your answer will be. If you don't read these two parts together, it's very difficult for you to be able to choose the correct option, because you may just take the reading, then you realize that you will choose 3, then you realize that the answer is 4. Okay, so this one very tricky question. The answer is 4. Okay, question number 15. Okay, John released a toy car at C on the ramp. Okay, as shown in the diagram, and it moved down to D. Okay, so it moved downward. Okay, so which of the following correctly shows how the car gravitational potential energy and the kinetic energy change as it moves from C to D? So as it moves from C to D, it's getting nearer to the ground. Okay, so if it's getting nearer to the ground, gravitational potential energy decreases, because gravitational potential energy is affected by mass and height above ground. Okay, so since it's getting nearer, so it should decrease. So only 1 and 2 is the correct answer, 3 and 4 out. So between 3 and 4, the whether kinetic increase or decrease, since it's moving downwards, right? It is actually increasing. Okay, because when it moves nearer to point D, right, the toy car will start to speed up. Okay, in that process. So the answer must be number 2. Okay, so question number 16. Which of the following is not? Okay, not. Okay, this is negative thinking question. Okay, which of this is not? So the answer over here is actually number 3, cooling hot water in the cup. So let's explain why 1, 2, and 4 they are energy conversion. When you climb up the stair, right, you're actually converting the food that you eat that is inside your body, which is, let's say, chemical potential energy. As you climb up the stair, you are converted to kinetic energy because there's some form of movement and you're going up above the ground. Gravitational potential energy. That is energy conversion. Charging a handphone, charging a handphone, so it will be electrical energy in the wire converted to chemical potential energy because this one is in the battery of the mobile phone. So there is energy conversion. Raindrop, because the raindrop initially is high up in the sky. It has GPE, gravitational potential energy. When it fall down, it will be converted to kinetic energy. So why is cooling hot water in the cup not energy conversion? This is actually heat transfer. Heat transfer, because the hot water loses heat to the surrounding. This itself is energy transfer. There is no conversion of energy involved in this case. So number 3 is the correct answer. So with that, we more or less come to the end of this MCQ paper. Please review your mistake. Thank you very much.